Alright, so that was a quick introduction last class to value at risk. Remember, last video, value at risk is the mean minus the standard deviation, number of standard deviations that we get from the table times the standard deviation. That's going to tell us our loss at a particular probability. If we do 2.33 as our number of standard deviations, then we're looking for an event that is a 99% event or 1% event, depending on how you're going to state it. Usually for risk, we talk about the 1% event, that there's a 1% chance that we'll lose this much or more. And in 1.65, it's the 95% down 5%. If you look back at the normal table, there isn't exactly 95%. I've seen some professors that actually require students to interpolate and find exactly like 1.6453, whatever. We're definitely not going to interpolate in here. These are already pretty guesstimate type of numbers. They're pretty high levels, so there's no reason to get that precise. So on the exam, just find a number close enough. I will not count off points if you use 1.64 or 1.65. That doesn't bother me. Or if you use 2.32 or 2.33, both of those are fine. Just find a number that's closest and go with it. And you can see with the 95%, they're exactly equal distance from each other, so either number is fine. Some professors would say use 1.645, but I'm not that picky for good reasons. We're really just in the ballpark on these. So we're going to be doing parametric VAR. So here's how it works. We're using statistics, usually in the normal curve, and I'll show you the normal curve. Hopefully you remember the normal curve, to determine how much a firm can lose at a given probability. So the first thing we have to do is select our risk tolerance. I will usually on the exam give you the risk tolerance. There's sometimes some questions where you actually need to calculate that risk tolerance, and I'll give you some examples of that. Use this a low probability event. The closer you are to zero, the lower your risk tolerance, the less risk you can handle. So if you have a 1% risk tolerance, that might be for a triple B rated firm. But if you're like when I was at USA using a 0.2% risk tolerance, that's more like a AA, AAA entity. So these firms, they're willing to risk an event that happens 1 out of 100 years or 1 out of 100 days, depending on how you measure it. This firm is only willing to risk something that happens 1 out of 500 years or 1 out of 500 days. Much lower risk tolerance. Most firm determine this by their desired credit rating. For individuals, probably the most important thing for individuals is how long until they reach retirement, or when they're going to need to start taking a distribution from their retirement plan. For most Americans, we use a 1%. Younger people might go up to 5% because they have plenty of time and they have a lot of years ahead of them. Older people, because especially those in retirement, might use a really low. Some people recommend how much do you put in the stock market. That's probably the most important decision you make, and they say take 100 minus your age, which means as you get older you need to reduce your stock allocation, but there's rules of thumb. But there is no precise way really to calculate the risk tolerance for the individual. We just generally use 1% for most people unless we have some indication. You may have seen risk tolerance questionnaires online. Those are interesting, but do not have a great deal of scientific mathematical support behind them. They're more just subjective. They feel precise and scientific, but they're really very, very subjective. So once we know what our risk tolerance is, and I'll give you what the risk tolerance is, we're then going to run VAR, calculate VAR. It says run the VAR, but we're going to just calculate it and determine our expected loss at that risk tolerance. So we have a VAR and our risk tolerance is 1%. Then we take the mean minus the number of standard deviations, which is 1%, the number of standard deviations will be 2.33, times the standard deviation. And we usually express VAR, even though usually you'll get a negative number with this calculation, we usually express VAR as a positive number because we know it's a loss. And so whatever VAR comes out, this is the amount we expect to lose or more 1% of the time. Now here's a normal distribution, so what we're saying is the mean's right in the middle, and we look at the number of standard deviation. Because we're interested in the losses, we'll be moving to the left. And so we'd say maybe this is 1 standard deviation from the mean, maybe this is 2, maybe this is 3. So if we go 2.33 standard deviations from the mean, 2.33 times the standard deviation and move that distance from the mean, then we're saying 99% of the time we're to the right of that, and 1% of the time we're to the left of that. Alright, we'll be doing some calculations of VAR here pretty soon. Once you have your VAR, you compare it to your risk budget. If your VAR is less than your risk budget, you do not need to do anything. If your VAR is greater than your risk budget, you can fire the CFO if they've made a mistake, and then you need to reduce risk somewhere. Some people cheat and they say, well, we'll just fix our model, we'll change our assumptions. But that's not good. It reminds me of a famous saying in finance, all models are wrong, some are useful. So some people use value at risk models and manipulate them to get what they wanted anyway, and that's not really a good risk practice. So you probably should stick with the risk budget. If someone's violating their risk budget and they're over budget, then we need to take action. So that risk budget, also known as risk limits, for some firms, their risk budget is their actual net worth. So they're really saying, what is the risk of ruin? That's what it's known, risk of ruin, because if they violate their risk budget, they're actually out of business. A risk budget for individuals is very subjective. Each individual has their own terms of how much they feel comfortable they could lose. But each person's different. And it really depends on, a lot of times I ask the question, how much could you lose and still meet all your financial goals? Let's make sure we don't risk you having to materially sacrifice, especially when I'm talking to people who are already in retirement and they have substantial wealth created. They need to really decide what's the most they could lose and still meet the goals they have for the rest of their life. So let's work some math examples. It's probably a little nebulous without putting some math to it. So these are examples, and again on Blackboard I'll give you some more examples. But let's say your Uncle Todd wants to buy some stocks in US, but he only wants to buy large companies. He says he has a risk tolerance of 1% and does not want to lose more than 20%. So his risk tolerance is given. That's going to help us get the number from the table. His risk budget is 20%. That's what he said is the most he's willing to lose with a 1% probability. And so he asked, can he invest all of his money in US stocks? If stocks are expected to return 8%, that means they have a mean of 8%. And a standard deviation of 15%, which is actually a pretty decent assumption for the US stock market. So his risk tolerance is 1%. If we look on the table again, since the table doesn't have 1% anywhere, this table is a mirror of the risk tolerance. So 1 minus 1% is 99%, so we're actually looking for 4.99 in the table. Some firms actually express the risk tolerance as 99%. At USAA, we always expressed it as the small percentage. At USAA, it was 0.2%. So we would actually be looking for 0.998, 1 minus 0.002. But some firms, they'll say our risk tolerance is 95%. So you just have to know, you can tell from context. But here, your uncle's risk tolerance is 1%. So you take 1 minus 0.01, you get 0.99. You find that inside the table. There's that 0.99. You then equate that with the 2.3 and the 0.03. You add those two together, and you're going to say, well, that is a 2.33 standard deviation event. So what we're saying is the stock market has a mean return of 8%. We want to go over to where the 1% event is, so we take 2.33 times the standard deviation, which is 0.15, and we find that. How far is that from the mean? And so here the VAR equals 0.08 minus 2.33 times 15%, and you get negative 0.2695. Your VAR at 1%, you notice how I always put the risk tolerance in my VAR. I just think that's very important so everybody knows exactly where you're coming from. My VAR at 1% is almost 27%, so he cannot put 100% in stocks because his risk budget is only 20%. This next one's kind of a crazy example, a little bit wild, but just to show you we can go either direction when we're looking at the normal table. So let's say Mary wants to retire in a year. She just can't take her job anymore. So she wants to find what gives her the best chance of meeting her goal. To retire, she needs to earn 28% on her portfolio because she hasn't been doing very, very well. And so when you look at these numbers, you can see which of these investments will actually be lowest risk. And here, low risk won't mean the same thing in the previous as in the previous example, because here low risk is something that has a higher probability of getting you 28%. So she could invest in bonds that have a 5% return, expected return, and a standard deviation of 5%. So she wants to make 28%, So you see here we're actually plugging in a target number. Her target number is 28%. 28% equals the mean plus the number of standard deviations times 0.05. Here we don't know the number of standard deviations. That's what we're actually calculating. We're trying to figure out the probability of her making 28%. So we subtract 5% from both sides. So we get 0.23 equals the number of standard deviations times the standard deviation. We get 0.23 divided by 0.05. That gives us the number. That's 4.6. Here we go to the table and we find 4.6, and you can see it's a number very, very, very close to 1. There's almost no probability with the bond fund that she's going to make 28%. So from her standpoint, that's a very risky investment. With U.S. stocks, a mean of 8%, a standard deviation of 15%. You can see the math here. It comes out to 0.2 divided by 0.15. So 28% equals 8% minus the number of standard deviations times 0.15. 0.2% equals minus number of stations times 0.15. We divide it all out and we get 2.2 divided by 0.15, so plus 0.2 divided by 0.15, we get 1.33. So 1.33, there's a 90% chance you'll make less than 28%, so there's about 91% chance you will make less. So only about a 9% chance that she'll make her 28% with that particular approach. If she uses emerging market stocks, 10% mean standard deviation, 28%, you can work through what that means. She could put all her money into one stock, has a mean of 8% but a standard deviation of 45%. And here you can see her probability of making that 28% is actually pretty good when you do the math. So I'll let you work through those math. This is kind of an unusual problem, so we'll practice a little bit more with that one. Let's try this question number 3. Your boss is interested in a new portfolio strategy. You run an analysis and determine it has a standard deviation of 8%. So I gave you the standard deviation first this time, so don't get confused. And expected return of 6%. Your boss has a risk budget of $15,000. So the other thing we need to see, you need to convert between a risk budget that's in dollars versus up here we had a risk budget that was in percent. So you need to be able to work either way. So he expresses it in dollars. The firm's risk tolerance is 1.3%. The portfolio value is $225,000. He asks, let me know if this strategy change will meet our budget requirement. So our risk budget is $15,000. Our risk tolerance is 1.3%. So let's go find that 1.3%. So remember what we do. If our risk tolerance is 1.3%, we take 1 minus 0.013. That means we're looking for 0.987 in the table. 0.987. 0.987 is about 2.23. 2.23 standard deviations. 2.23 from the table. So our VAR at 1.3% is our 6% minus 2.23 times 8% gives us an 11% loss. So $225,000 times an 11% loss means we expect a loss of $26,640 or more, 1.3%. That's well above our risk budget of $15,000. We can't do that. Alright, so this is what we'll practice with on Blackboard. I will give you more examples so you can practice more. These tend to be the easy ones. Number 1 and number 3 tend to be easy ones. The ones the students struggle on are number 2 when I ask you to figure out the probability. So we'll need to practice both directions, but it gives you some practice and then you can look at the other problems. And then where we'll start with next on Thursday's class is we'll get into this issue. We're not going to do it too much in here. We'll get into this issue of what happens if you have more than one thing you can allocate to. That's when the consideration and correlation comes in, and that's where we're going to deal with a very famous formula in finance, which is how to handle a portfolio has more than one thing in it. How do you get the risk of that entire portfolio, given that they're not perfectly correlated? We'll have to adjust for that. And then we'll also work on how to actually do a correlation graph and actually build an efficient frontier in class, and I'll show you how to do that. So it's an exciting topic because we use it a lot in finance. You see it a lot in finance. It's a powerful tool. It definitely has its weaknesses, but it's a powerful tool. So what we need to get comfortable with in Thursday's class It's just keep practicing these items, and you have some practice problems in your homework that look a lot like what you'll see on the exams. So not a full 75-minute class, but at least gets us so we don't get too far behind by missing Tuesday's class, and also gets you a chance to get started on the next homework on value at risk. Thanks.